Velocity data in SegWy format can be loaded using the Insight SegWy Loader, as you would a normal seismic volume. Just remember to set the class to velocity during loading so that it is recognized as velocity by Insight. A lot of velocity data comes in ASCII format, which must be loaded using the ASCII Loader in the main Doug Insight import menu. In this short tutorial, we will review the steps for importing ASCII velocity in column format. Column formats are very common and can be used to describe SOV2 and Disqus formats amongst others. Here are examples of ASCII 2D and 3D column formatted files, which can be opened in any text editor and easily reviewed. These 2D SOV2 files have headers, which are useful to understand the history of the file, but they are ignored during import. Column formatted data will vary, but the general feature of 2D data is that it must contain a CMP value to match the existing 2D lines as well as the Z velocity pairs for each location. Once you understand the format of your column-based files, select the Import Volumes ASCII Volumes menu. Select the 2D depth velocity model in SOV2 format. The ASCII volume loader is very similar to the SegWy loader. Simply complete each window of the wizard and click Next to progress through to the end. A 2D column-based volume must be stored as separate lines, where one file is one line. This velocity data exists for 4 2D lines, and so there are 4 files to select. The 2D line name is taken from the file name and not from any keywords inside the file. The file names in this example are a combination of the line name and the data type and do not match the line names already loaded to Insight. The line names can be manually edited to match the lines in Insight, or, as in this case, you can strip the suffix, leaving just the line name. The software has detected the number of header rows for this recognized SOV2 formatted file. But if the software cannot pick up the header rows, you can manually set the number of rows to skip. Select the matching drop-down column description to the 3 columns that represent CMP, Z value and velocity. Note that with SOV2 format, the CMP column is often a combination of the CMP value and some other characters such as the line name, or as in this case the letters RMSV. You can strip the unwanted characters using a prefix or suffix match so that they are ignored during import. The ignored characters are highlighted in red. Run the analysis for the wizard to understand the size of the files and to check for any potential problems. Red text is an error and means you need to go back and check your data and settings. The blue text here is good and means everything is okay. The orange highlight here is just a warning and helps to understand if any changes are required. Hovering on the highlight provides more information on the warning, which in this case shows the files have an irregular CMP spacing or time interval. If the survey does not exist, you can create or import it here. In this project, the survey already exists and is selected. However, only 4 lines are being imported, which are listed at the bottom of the line list. The green text confirms that the line names have been matched and that the CMP range is valid. Finally, set the volume name. In this example, I will copy the file name which captures the PSDM origin of the velocity as well as the RMS velocity type. The name is useful to the interpreter, but it is the class that is recognized by the software for process calculations. Set the class to the correct velocity type, in this case RMS. Done. Let's look at a more generic column formatted file for the 3D data. This file is not a standard format and has a simple 1-line header describing the 6 columns of X, Y, inline, crossline, Z and velocity. After selecting Import Volumes ASCII, select the 3D time velocity model in custom column-based format. Most 3D velocity data comes in a single file, but it is possible to select a single volume spread over multiple files if necessary. select the matching drop-down column description to the 4 columns that represent inline, crossline, z-value and velocity. In this example, the header has not been recognized and must be manually assigned. Run the analysis for the wizard to understand the size of the file and to check for any potential problems. The survey for this example already exists and is automatically selected here. If this was the first volume to be imported, a new survey would need to be created or imported before proceeding. Finally, set the volume name, which is useful to the interpreter, but remember that it is a class that is recognized by the software for process calculations. Set the class to the correct velocity type, in this case RMS. Done. Always QC your data after import. Viewing the data in the original format is a start. There are some very vibrant color bars in Insight which will reveal subtle changes. RMS velocity has a gradual increase with depth and is unlikely to reveal any problem values. Use the velocity conversion process to convert to interval velocity for a more detailed QC. This smoothly varying interval velocity looks great. There's a lot more detail in this case, including the high velocity layer towards the top of the section.
If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight!